Okay. Oh, I'll turn off that front light. Okay, exponential models with differential equations. All right. D sub y over at d sub x equals x. This is not a logarithmic exponential one. This is just to get your minds around this again to remember what we're doing. So how do I do a separation of variables? dy equals x dx, right? Okay, then what do we do to each side? Integrate. 1/2 x squared plus c. Got to remember your plus c. Then you plug in your variables. So 2 equals 1/2 of 4 squared plus c. So 2 equals half of 16. Excuse me. So 2 equals 8 plus c. C equals negative 6. So y would equal 1/2 x squared plus 6. Minus 6. Come on, Mr. Bierschbach. Okay? That's fairly straightforward. Too bad Ashlyn wasn't watching any of that. So now we're going to do it, except for what's going to happen to our y? Yeah, it's going to go to the other side in the denominator. So 1 over y dy equals dx. Same number, same everything, but now our y goes to the other side in the denominator. So when we integrate 1 over y, what do we get? ln of y equals x plus c. Okay, plug in the numbers. Well, no, let's e both sides first. So if we e the ln of y, we get y. So it's e to the x times e to the c, because x plus c is the same as e to the x times e to the c. What's e to the c? It's c, so it's c e to the x. So if we plug in our numbers now, 2 equals c e to the 4th, divide by e to the 4th. C equals 2 over e to the 4th. Plug that in for c. So y equals 2 over e to the 4th, e to the x. And then what's e to the x over e to the 4th? E to the, when we divide, we subtract. And there we are. Okay? That's how to do exponentials. So, knowing that, the amount of medication in Rory's bloodstream decreases at the rate proportional to any time that the amount of the medication is in the bloodstream at that time. This sounds like a total nursing question for those of you who are future nurses or doctors or things like that. Rory takes 150 milligrams of medication initially. The amount of medication is halved every 13 hours. How many milligrams are in his bloodstream after 8 hours? Such a good problem. Okay, so if you know it's an exponential function, y equals c e to the x t. Okay, well, how do I get that? Yeah, I jumped way too far ahead. You got to see how to do that. Okay, the amount is in his bloodstream decreases at a rate proportional to any time the medication is in the bloodstream. So the amount over the time is proportional k times at any time decreases at a rate proportional to any time the medication is in the bloodstream at that time. So it's, oh, Mr. Bierschbach just had a brain malfunction here. I think the amount, I think it is something like this, but it decreases at a rate proportional, so it's negative. So the amount of medication decreases at a rate that is proportional to, at any time, to the amount of medication is in the blood at that time. Let's go with this and see where that gets us. Okay, so we move the a to the other side, we move the dt to the other side. So 1 over a dA equals negative k dt. Okay, so you integrate both sides. The ln of a, the amount, equals, k is a constant, so we can throw that on the outside. And the integral of t of nothing dt is t. So if we e both sides, plus c. So then amount equals e to the negative kt, e to the c. So the amount equals c e to the negative kt. All right. So the initial amount. At what time is the initial amount? At time equals what? Time equals 0. The amount is 150. So 150 equals c e to the 0 power. Okay? What's e to the 0? 1. So c equals 150. So if it's anything initial, c is going to be the initial amount. Okay? So the amount equals 150 e to the negative kt. All right. So what's the amount of medication? The amount of medication is halved every 13 hours. So whatever the amount is, it's halved 13 hours later. Well, if it starts at 150, you have 75 13 hours later. See where I put my numbers? Okay, the half amount. So if we divide by 150, 0.5 equals e to the negative 13k. ln both sides to get rid of your e. So the ln of 0.5 equals negative 13k, and divide by negative 13. So k equals the ln of 0.5 divided by negative 13. Now, how much is left after 8 hours? The amount equals ce to the kt, 150. E, k is the ln of 0.5 over negative 13 with a negative in front of that. I think I'll have to see about, check on that negative. That negative is the only thing I'm really wondering about. And then the time is 8 hours. So you grab your calculadora. That would be if they're, yeah, so that there's not a negative there. All right, calculator. VTI. So if we take 150 times e raised to the ln of 0.5, close that parenthesis, divided by 13, close that parenthesis. What do we get? 142, which seems really high. Oh, I didn't take it times 8. Didn't take it times 8. So that same thing up there, enter, up here, times 8, enter. 97.9, which is 98. Okay, there's a process to this. There's a little process to this. So that's what we need to do. The mass of an isotope decreases at a rate proportional to the mass at that time. So the mass, so dm dt equals proportional to the mass at that time. Km decreases, negative. Okay. I wonder if I need the negative there. I think that's going to screw us up. Because then if I do the math, then the k should wind up negative. And if you just plug it in for k, then that works out. I think we need the negative. All right. So 1 over m dm equals k dt. Remembering k is a constant, so it goes on the outside of the integral because we're not integrating k as a variable. It's a constant. It's a number. So the ln of m equals kt plus c. So what do we do to each side? Well, we e it. So m equals e to the kt plus c, which is the same as ce to the kt. So it was 40 grams initially. So what is c? 40. Let's solve for k. So it's 10 grams after 16 days. So divide by 40. So 0.25 equals e to the k16. ln each side to get rid of your e. The ln of 0.25 equals 16 times k divided by 16. That's what k equals. So m equals 40 e to the ln of 0.25 over 16 times, we want to know after 20 days. Grab the calculator. 40 e to the ln, no, the ln, Mr. Bierschbach, ln of 0.25 divided by 16, close that, times 20, 7.07. It was 40 initially, 10 after 16, 7.07 really makes sense after another 4 days. Okay? So, that's the basics of how you do that. Do you want to do one more here? No. Maybe we should. During one time period, the price of rhodium increased at a rate that was proportional to the price of rhodium at that time. So dp dt, the price, equals p kp, proportional to that. So 1 over p dp equals k dt. Integrate. So p equals e, no, come on, don't jump ahead. So the ln of p equals KT, and then we E both sides. So P equals CE to the KT. Notice how this is the same pretty much every time.
Yeah.
We can kind of jump to that. If it's not like if it's increasing at some crazy thing, but most of the time it's at a rate proportional, so it's CE to the KT. The price of 1 ounce was that initially, so P equals 475 E to the KT, quadrupled every 25 months. What is quadruple of 475? 4 times of 475. So that'd be 950, 1900?
Yeah.
So if we divide by it, 4 equals E to the 25K. K equals 4 over E to the 25. Wait, what did I do? I need to natural log that at the step before. So the ln of 4 equals the ln of E to that. Yeah. So the ln of 4 equals 25K and divide by 25. That's a better way of writing it. So P equals 475 E to the ln of 4 over 25 T. So we want 18 months, so you just put an 18 in there. So it's 475 E to the ln of 4 divided by 25 times 18. 1288 point whatever. Okay? So that's the process. The first ones are going to be kind of like this, where you're just figuring out the equation.